1. 5G will use new radio called millimeter wave. As we know, radio frequency spectrum from 1 GHz to 6 GHz is very crowded. Many technologies use this range, such as GPS, WiMAX, Wi-Fi, 4G, 3G, L-band satellite, S-band, and C-band satellite, etc. The spectrum range from 30 GHz to 300 GHz, known as millimeter wave, is less utilized, is a new territory. Thus, the range from 24 GHz to 100 GHz is proposed for 5G. The millimeter wave has at least 3 advantages. 1. It is a new and less used band, as we mentioned before. 2. Higher frequency wave carries much more data than lower frequency wave. And the third advantage is millimeter wave makes it possible to have massive MIMO antenna, which is the second 5G technology. The relationship between the wave frequency and antenna size is inversely proportional, which means lower frequency signals need a bigger antenna to transmit and receive, while the higher frequency signals can work well with the smaller size antenna. The higher frequency wave we use, the smaller antenna we can get. Thus, millimeter wave makes it possible to have a lot of transmitters and receivers installed on a small size cell or panel. For example, for older technologies, one cell can have 10 antennas, but for 5G, the same cell may have, let's say, 100 antennas. Thus, one small cell can handle many more users at the same time. The third technology is also related to millimeter wave. Millimeter wave has advantages, as we mentioned before, but it has some disadvantages too. For example, higher frequency signals will have more collisions with obstacles in the air, and thus they tend to lose energy more quickly. Therefore, millimeter wave signals cover shorter distance. They are also easily blocked by building or trees. To solve these problems, small cell stations are needed to fill in coverage gaps between the base station and the users. Each cell station covers a small area. The number of small cell stations and the distance between them depends on the population at that location. In a highly populous district, for example, the distance between two small cells could vary from 10 to 100 meters. In the near future, you might see such small cells everywhere in your neighborhood. The fourth new technology is called beamforming. In 4G, the wireless signals, if not omnidirectional, are spreading over a large area as they travel. Thus, signals tend to lose energy more quickly. To make things worse, different users might interfere with each other if they are standing close. Beamforming makes the transmission between the users and the base or cell stations more directional. It can be visualized as laser beam between them so that signals seem like traveling along an invisible cable. The high density of beamforming leads to less interference and less energy consumption, and thus a fast data rate can be achieved. The fifth technology is NOMA, non-orthogonal multiple access. In previous generations, 1G through 3G, Multiple access methods are based on frequency, time, and code. In 4G, orthogonal multiple access is used. The key idea of NOMA is to use the power level of user devices to access the base station. The new multiple access method would allow different signals share the same channel simultaneously, but NOMA provides a higher sum rate than orthogonal method. These two access methods, orthogonal and non-orthogonal, would be two separate videos on my channel. Here I try to skip the details, otherwise this video is already too long and too boring. Last but not least, mobile edge computing. The mobile edge computing, or MEC, utilizes the cloud computing, but brings cloud computing closer to users. In normal cloud computing environment, there are several drawbacks, which include 1. Cloud service could be far away from users physically. The distance always makes difference. Longer distance would easily create latency. 2. Many data and applications need downloading to users' devices. It would be too much burden to users' device, especially for the device with limited processing power and memory. Mobile edge computing brings cloud computing and services to the edge, which is closer to the user. They are physically local to users. Intensive and latency-sensitive applications like the augmented reality video conference can be hosted at the edge of the network. Application splitting is another benefit. This would enable application to be split into small tasks, with some performed at the device and some at the cloud.